Hi, welcome. In the last lecture, we had discussed about the types of testings, unit, integration, systems. These are the three levels of testing. Then we have regression testing, which is a different dimension of testing. And we had looked at some very basic concept of unit testing and integration testing, the system testing. We just started discussion. Now let's proceed further. We can consider system testing to be two types, either a functionality test or a performance test. In other words, if we have to do a system testing for some software, we have to write two types of test cases. One is the functionality test cases and other is the performance test cases. We will see what the functionality test need to test which aspects and which aspects will be tested by the performance test. We can also consider the system testing to be of three types based on who performs testing. There are three different types of system testing. The alpha is done by the developing organization. That means the tester in the developing organization. This is the type of system testing which is first performed and after the system passes the alpha testing. Beta testing is performed by the set of uh, customer and friendly customers or users. And after all the issues that arise during the beta testings are addressed, the acceptance testing is performed and acceptance testing is performed by the customer. Once the system is delivered to the customer, perform the acceptance testing and they accept the software if it passes the acceptance, otherwise they return it. They do not accept it. Now, as we proceed, we will look at the functionality test. The functionality test is basically all the functions that are documented in the SRS document. This test whether all those functions are working fine. The second category of tests that we had to be developed the test cases and to be executed are the performance test. The performance test determine whether a system or a subsystem satisfy the non-functional requirement. So both the functionality and the performance test in system testing are designed based on the SRS document. The functionality tests are designed based on the functional requirement and the performance tests are designed based on the non-functional requirement. There are several types of non-functional tests. The response times, whether all the response times are not met, throughput, usability, stress, recovery, configuration, etc. There are many types of performance tests. Later in this series, we will see what are the aspects that are tested in these different types of performance test, like the throughput, usability, stress, recovery, configurations. Just to have some more basic ideas on testing. Once the software is delivered to the customer performs what is known as the user acceptance testing or the acceptance testing. They just check whether the system fulfills all the requirements and based on their test, they either accept or reject the software. No, based on our discussion so far, we can see that a software is tested by different types of personnel. One is the developing team in the developing organization, the programmers who wrote the programmer, they perform the unit testing. They may also test the other programmers code if necessary. So the programmers themselves are one type of tester. The users that perform the usability and the acceptance testing, and some of the friendly users, they may do the beta testing. Then often the organization have a separate testing team and they do all the testings like the integration testing, alpha testing, and so on. So they do most of the testing accepting the unit, beta, and acceptance testing. And also they develop the test strategy, that what kind of test need to be performed, and they also develop the test plan when in what sequence the test need to be applied. Uh, if we look at the broader picture, In the development life cycle, Weather shown an interactive waterfall model. In this initial stage of waterfall model, you can see that the review is done after the end of the every stage. The SRS document is reviewed during the requirement analysis and the specification during the design. Design document is reviewed and the code is reviewed, and there may be a necessary to simulate this, and these are all done by the developers. So in the initial stages, the testing is done by the developers, but during the test stage where the integration and system testing is carried out, the testing is done by the user. Now, let us look at another very important fundamental concept of testing. This concept goes by the name pesticide effect. This concept is given the name pesticide effect because of it is analogy to be used of pesticide in a crop field. Let's assume that we have a cotton crop, and then the farmer found that it is the infested with pest. So what does the farmer do? These are the pests who have infested the crop, and the farmer would apply some pesticide, and then most of the pest gets killed. But then few of them are still survived. Now, in the next season, when the farmer plants to crop, again those which are survived, they multiply and also new types of pests come. Again the farmer applies the pesticide, but then if the farmer applies the same pesticide, let us say DDT, those which have survived DDT, again applied the DDT will do nothing to them because they have their resistance to DDT. So the farmer needs to apply a new type of pesticide, let's say uh, malathin, and then many of the pests get killed. But then those which survived, and again they appear in the next crop, multiply and appear, and a new types of pest appear. But again applying the malathin, we will do nothing to this pest because they had survived malathin, and malathin now does not kill them. So the farmer needs apply some new other pesticides. In testing, it is the same thing. There is a very strong analogy with the pesticide effect in the crops. We can state by saying that error that escapes a fault detection technique cannot be detected by the further applications of the technique. What it means is that we have many types of testing techniques, dozens of the testing techniques. We will see some of those may we will look at a dozen, but there are each time we apply a testing technique, some of that faults are detected, but then some of the fault escape. And if we again and again apply the same testing techniques, we will be not detecting those which had already escaped, because this testing techniques does not detect those kind of faults. So we need to apply new type of testing technique or a different type of testing technique, and we catch some of the faults and again apply another testing technique. So the bugs which escapes a testing techniques, further application of that same testing techniques, we will yield very little result. That is the reason why in the software development organization, several type of testing techniques are used, one after other. This is called the pesticide effects. Uh, Capers-Jones, who is a well-known researcher in the various testing, had written an article in the IEEE 96. He had proposed a rule of thumb in the article. It states each of the software review, inspection and test tail will find that 30% of the bug present. So what he say is that each of this can be considered as a bug filter. In a review, we get some bugs exposed. During the inspection, we will get some more bugs exposed. And then there are there are various types of testings, and each of those we get only 30% of the bugs present. So initially, if the code had 1000 bugs review, we'll catch 300 of them. Out of the remaining 700, 30% is the 210, and 210 will be the obtained by the inspection, and then we have 490, and out to 490 apply unit testing, we will get the 30% of that, which is about the 182 and something, and so on. So that is the one we had experimentally observed, that each of the software inspection and testing techniques can be considered as a bug filter, and this bug filter can find 30% of the bugs present. Now let us do a small arithmetic. Small problems based on these pesticide effects. Assume that we had 1000 bugs and we deployed four fault detection techniques, and each technique is highly successful. Unlike what Capper's John had written, our techniques could detect 70% of the bugs existing at the time. So after the application of four detection techniques, how many bugs should remain at the end? So we can do it initially. After the first technique, 300 will survive. 70% will get detected out of 1000. So that is the 700 detected in the 300 existing, and then again 30% of that will survive, and so on. We can do it quickly when nothing that is equal to 1000 into the 0.32 power 4. So because each time only 0.3 survive. So the total surviving bugs out of the application of these techniques is 81 bugs in this program. This is a big number of bugs, 81 bugs. When the users encounter these bugs in the failure, they would be extremely unhappy and they will call it as a poor quality of software. Therefore, we need to have many more bug filters, such as the bug reduce the very small level. No, let's have a small quiz. Given that this is the iterative waterfall model, when exactly are to be verification tasks undertaken in this model? In which stages are the verification work undertaken? The verification, the form of review, inspection, simulation are done during the requirement analysis, design, and coding. That is answer. When is testing undertaken in waterfall model? So answer this, you can say that the unit testing is done during the coding stage, and the integration and system testing is done during the testing stage. When is the validation undertaken in waterfall model? Validation, if we remember from our last lecture discussion, validation is basically system testing, and system testing is undertaken during the testing stage. Now let us look at some more basic concept in the testing. Let us assume that you have tested one software very thoroughly, and let's say developing organization developed a large software and then tested it very thoroughly using the available techniques. How many errors will survive after all the testing activities are over and success report for all the tests have been obtained? Several studies have been undertaken on this issue, John, uh, but then they conclude that a typical testing process remove 85% of the error and 15% continues to stay, and those are called as a latent errors. But why cannot we remove more errors? Uh, cannot the testing techniques remove 99.99 or 100% of the errors? Why they remove only 85% of the errors? The answer to this question is that all the testing techniques that we will discuss are basically heuristic techniques, and they do not guarantee that they will detect all the errors. So all the testing techniques are heuristics. They help to reduce the bugs but provide no guarantee of the complete removal of the bugs. This is an important observation. That is, all testing techniques which you discuss are heuristics. They help only to reduce bugs, do not provide any guarantee concerning complete removal of the bugs. Okay, thank you.